Hi everyone, my name is Johnson. My reach number is URK18CS213. Today we will discuss about the process synchronization methods that is producer consumer problem and the reader writer's problem. First we will discuss about the producer consumer problem. Then we will discuss about the reader writer's problem. In these two, how the process synchronization will be doing the process in these two methods. In the producer consumer problem, uh, it is used for multi-process synchronization, that is between the more than one process. It can do the process at a time of multiple process can do by the CPU of process synchronization. Now, in the producer consumer problem, we can see that in the word we can see that there are there is two, that is one producer and the another one is consumer. What is the useful of producer and what is the consumer in this problem is the producer always produces the items into the buffer, and again, and after sending the buffer it is automatically generates, and again it will generate the items into the buffer. And what the consumer will do, the consumer consumes the item from the buffer produced by the producer. This is the function in the producer consumer problem. What the producer will do, the producer add the items into the buffer, and the consumer consumes the items from the buffer and take it. And this is and the main thing is, when a producer should not produce items into the buffer when the consumer is consuming item from the buffer. For example, a producer is consuming sending some information to the buffer. When it is sending the information to the buffer, the consumer can take. But when the consumer is consuming the buffer, the producer should not send the information to the buffer. This is the main thing in this. We have in the main job of the producer is to generate the data and put into the buffer, and again starts the generating the data. Okay, in this there are two types of the producer consumer problem is will solved by using semaphore. In the semaphore there are two methods, that is wait and signal. The wait operation reduces the value of semaphore by 1, and the signal increases the value by 1. Now in this we will use some functions. For the semaphore mutex, if the value is 1, uh, semaphore mutex initialized to the value of 1. If it is full, it is declared the mutex equal to 0. When it is empty, it is initialized to be value of n. Now we will see the program. Now for the better understanding of producer consumer problem, here we will see some real life example. That is, here when the delivery boy is keeping the packets in the auto, he is producing the items into this vehicle. This vehicle is known as buffer, and this person is keeping the items in this buffer is known as producer. When he had some person has ordered some product in Amazon called as one smartphone, he has ordered in that. uh, when he ordered the phone, the producer, that is the who he has ordered, he will be packing all the items which the user has sent, the this type of phone I want and this type of RAM, all that he will be packed and send it to by the user, that is known as consumer. And this is when it is delivered by the auto, that is buffer. And after it is sent into the buffer, the user will take that items which he has ordered, that is known as consumed. If producer needs to wait if buffer is full, if producer needs to wait if buffer is full, if the auto is contains only 15 items in that, if we producer want to keep 20 items, it is not easy that. If we want to be empty in that buffer, the consumed had to take that items from the buffer, and it will be some space to keep by the producer. Now this is known as producer consumer problem. The producer need to wait if buffer is full, consumer needs to wait if buffer is empty. Okay, this is the real life example, and the one more important point is the producer consumer problem is also known as bounded buffer problem. Here the buffer is in fixed size. Now let's see the program of that. Now the program I have written in C++. Now I hash include iOS stream. These are the input libraries. I have taken some functions as int mutex equal to 1, full equal 0, empty equal to 5, x equal to 0. Now here I have told mutex equal to 1 and full. If the buffer is full, I have taken that, and empty equal to 5. Here I have told that we will use the semaphore, that is two values, that is weight and signal. Weight is to reduce the semaphore value by 1. So I have taken here int weight of int s, it will be decreased. When weight comes, it will be decreased by the semaphore. And here I have taken the signal operation int s, and what the signal operation will do, it will increment the value of semaphore. Now I have taken what the producer will do, mutex equal to weight of mutex, full equal to signal of full, empty equal to weight of empty. Now when the producer is sending the items to the buffer, if the buffer is full, he has to wait until the consumer produces the items from the buffer. Now here I have taken that mutex equal to weight of mutex, full equal to signal of full. Now when the buffer is full, the signal will activate, and it will tell that buffer is full. If it is empty, if the buffer is empty, only the producer can send the products into the buffer. Now it will be x plus plus cout, producer produces the item, mutex equal signal of mutex. What the consumer will do, which the items are sent into the buffer, it will be consumed by the consumer. Now here when it is empty only, then the producer can send the items into the buffer. Now what the consumer will do, consumer consumes the items from the buffer, mutex equal to weight of mutex. Now consumer has to wait until the producer sends the items into the buffer. Now here when the producer stops the process sending to the buffer, then only the consumer will activate, and he will be consumed the items up to the buffer is empty. Now here full equal to weight of full, empty equal to signal of empty. Now here I am in main function, that is here switch case I am using entry word choice in. If you want to producer or consumer, if mutex equal to 1, empty is not equal to 0. If that is buffer is full, if mutex equal to 1, empty is not equal to 0, then producer. If buffer is full, will be printed. If mutex equal to 1 and full is not equal to 0, then the consumer will send the message as buffer is empty. Now we will just see the output of this program. When we see the output here, it is asking entry word choice that you want to produce the items. First in the buffer there is no items. Now we will produce the items into the buffer. Now we can see that I have entered the choice as 1. I have activated the producer. Now the producer will send the items into the buffer, and I will 2. Then it will be then the item is produced by the producer will be consumed by the consumer. Now here I am all sending into the buffer. This is the output of this program. Now let's discuss about the next next process synchronization, that is reader writer's problem. Now in the reader writer's problem, when we see that in the word, we can see that there are two process, that is reader and writer in this process synchronization. In this also we are using reader writer's problem by this semaphore. Now when we see about the reader, if two readers access the object at the same time, there will be no problem. But if two writers are a reader and writer access the object at the same time, there may be some problems. When, for example, if the writer is accessing on an object, no reader can access to the terminal. And now when we see the program of that, here I have taken some variables as semaphore write mx and int numerator equal to 0. And here when I have said that if when a writer is accessing the object, no reader can enter into that. But when a reader is activating on that object, the multiple readers can act on that. But in the writer, when the writer is acting, the only one writer can be access to that object, no reader and no another writer can access to that. But when you're reading the object, the multiple readers can act on that object and read. But the write operation, we cannot do that. This is the difference between that. Here when we see that void reader void number, that is number reader plus plus, if number equal to 1, same weight. If here number of reader equal to 1, we have to wait and we have to give to that the write operation should be performed on that. When same weight of mutex num reader should be decremented. When the waiting time of mutex is when the waiting time of mutex, then the number of readers should be decreased. If number of reader equal to 0, it should be same post and it should be written. And when we see that main function pthread, I am acting the thread function here. If we want to activate that, if the writer is accessing the object, no reader can act on that. So I am using here thread methods, that is sleep methods I am activating here. Now let's see the output of this program. Now here see, when we see that reader 1 reader read count as 2, and reader 3 read count as 1, read count as 1, read 4 read count as 1, read 5 read count as 1. Here all the readers can be access at a time, but the writer option we cannot perform multiple operations on that. Only for example, if you are writing a if you are writing one matter in that paper, someone else cannot write on that paper. This is the problem. When we are reading a story in a book, some other members can come and read. This is simple logic for this program. We cannot perform multiple writers in this when on that object, but the readers can multiple readers can activate on that object. Here writer 1 modified count to writer 2 modified count to. This is the output of this program. Thank you. We have seen that producer consumer problem and readers writers problem, the process synchronization method. Okay, thank you.